All right, so guys, quickly, we looked at electrochemistry in our first session, and we're dealing with what? Redox, basically, the foundation. And we identified 10 ways of identifying the anode and cathode. For me, that is the most important. You would see what I mean by that's the most important. We're just going to apply these things. But there was one that I missed that I need to quickly add. All right, the flow of ions. So we said oxidation is the loss of electron. I'll be applying a lot of these things today and also interpreting them for you. So it's not just about writing, it's about interpreting immediately you get the information. Okay, we said there are 10 things. We wrote 10. Number 1, oxidation occurs at the anode, reduction at the cathode, hence the word red cat. Loss of electron would occur at the anode, and gain of electrons will occur at the cathode. Number 3, the flow of electrons, because of number 1 and 2. Electrons would move from the anode to the cathode. Number 4, the anode is the one that decreases in size, while the cathode will do what? Increase in size because of reduction. Let me put an equation for you here for you to see something. I'm already starting with my applications. So you can go back to your table and make a note. Here, this is what and we did a bit of equations last week in our first lesson, where we copy cat. This week, I can say last week. All right, for example, check it. I'm going to have zinc 2 plus aqueous. And aqueous is an ion that is invisible to the eyes. You cannot see it. Plus 2E. And I will be having zinc solid. I know I did mention that. You see, a solid is now formed. All of a sudden, you're beginning to see a solid. What happens to the size? It increases because a solid begins to form. I don't know if that makes sense. And that's reduction. A solid begins to form. Aqueous is invisible, so I cannot see this guy. It's like asking you, what makes up water? Hydrogen ions and oxygen. Can you see the oxygen ions? You can. But can you see water? Yes. Right? So if I have water solid, what happens to the size? It has what? Increased. Okay, so that's one thing you must always remember. So the cathode will increase. On the other side, look at what's happening to the anode. Zinc becoming zinc 2 plus. I tried to explain this as well, saying you have a cube of sugar that begins to do what? Dissolve. So you would see that the solid visible. And then your aqueous becomes invisible. This is why the anode will decrease, because something you can see and all of a sudden begins to dissolve into the solution. You can no longer see it. Good. That's beauty electroplating as well, because when it comes to electroplating, you can see. And if you can see it, the size automatically does what? Increases. So we're using the anode to cover the cathode. All right. So we mentioned a few of those applications because as I get into content now, I need you to quickly drop down all of those applications. Oh yeah. Okay, that's what it is. This is what's happening. And that's why it took a whole 2 hours to explain anode and cathode reactions. Okay. Number 5. I've got to move now. Number 5. We said the anode, that's where you have your reducing what? Agent. What is the reducing agent? A substance that loses electron. So it is oxidized. Remember, oxidation occurs at the anode. And the oxidizing agent would be at the cathode. I'm going to look at that more today. Number 6, we look at E values. The more negative is at the anode, the more positive is at the cathode. Remember, the word more positive doesn't necessarily mean it's positive. Today we're going to be looking at how those values were gotten. All right. Number 7, we looked at polarity. The word ape is going to be our guide. Anode is positive in the electrolytic, while the cathode is negative in the electrolytic. And when you switch it again in the galvanic, which is we're looking at today, anode is negative. And that.
Is it positive? Because like electricity moves from the positive terminal.
I'll show you why it's positive. I'll explain why it's positive. Number 8, electroplating. Materials used for electroplating is at the anode, just like what we see at the cathode, we see. So that should be that. Number 9, we said electro what? Refining. Impure metal is at the anode, pure metal. The same process. I just like breaking things down. And then number 10. Can I then add number 11 quickly? Number 11. The anions move towards the anode. No, it's just one line. No matter the cell, whether a galvanic, whether an electrolyte, no matter the cell, the anions will move towards the anode. And what thing that will guide you is the anion. Anode, the anions would move towards it. Cathode, the cations would move towards it. So the cations move towards the cathode. All right, so that's, you have 11 ways. I literally have covered everything. I promise you there's nothing they want to ask on how to identify anode and cathode that I haven't looked at. All right. Are we still okay there for those of you at home? Can you still hear me? Okay. Nyabonga Baba. All right. So those are 11 important and vital ways. From there, we started looking at what? Half reactions. Remember, all of these are just, now these are cherries on the cake, you know, your cream on the cake, because now you can identify your anode and your cathode. You're just reeling in a lot of marks now, 2 marks, 3 marks there, blah, 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 blah. All right, so I'm not going to spend time on this. I'm going to come back when it's necessary. We looked at how to use the formula as well, right? Okay, you know I like my multiple choice. Okay, but not now. Not now. I'm okay on yourself. Okay. All right. Guys, quickly. Today, spontaneosity. That's very, very important. I want to quickly give you 4 marks. And this is what's going to lead me to a galvanic cell. All right. Spontaneous reactions. I'm going to be very fast today because I want to finish. We do not have time. Spontaneous reactions. When we say spontaneous reactions, what is the story? I cannot deal with galvanic without telling you about spontaneous reactions. I'll be doing injustice to you. No, not table. Spontaneous. Number 1, it's a reaction that occurs on its own. A reaction that occurs. Those of you doing life science, you should be able to relate this to your life science because it's like a reflex. All right, I want to poke you. You just react on your own quickly. It's spontaneous. No, I'm not going to do life science. I'm not. I should give you exam guidelines for life science. Oh. Okay. Ribotile, you just came in. Please settle down. Ribotile, we added 1 point to the table. Yeah. You just came in, so leave me alone. Already firing.
You fighting your PA?
I don't know where my PA is. I'm officeless these days. Okay. Number 1, a reaction that occurs on its own. All right. Number 2, I wanted to quickly be looking at this. Number 2, the EMF is positive. The EMF value. You remember how we're calculating the EMF value? Positive. Number 3, and this is important, the reaction is exothermic. It releases heat. Here we're saying what? Enthalpy is less than what? 0. Very important, 3 points. Number 1, it's a reaction that occurs on its own. It's like your battery. Do you do anything for your battery to work if you buy a battery from the shop? No. Yeah, it just starts working. So it's spontaneous. All right. The EMF is positive. You will see them. You will never see a battery that says negative 1.5 volts. Don't buy it.
So are you spontaneous?
Some ways I am. Number 3, the reaction is exothermic. Your battery is always warm. Go back to when you get back home, go and look at your wall clock. Just touch it. It's warm. It's an exothermic because a battery is a galvanic cell. We're going to look at that. All right. Okay. All right. Now, how do I identify? And this spontaneous reaction has different applications. The first application is what we're going to look at now. The first application of spontaneous what? Reactions. Okay. How to identify spontaneous reactions. Hence, I'm quickly looking at applications. All right, let me first look at how to identify. Number 1, identify what is oxidized and reduced. Number 2, write out half reactions. So I'm going to say redox. You have to write out half reactions. So first we identify. We had 10 ways of identifying, 11 ways of identifying. Now you do what? You write out your half reactions, which we use the table for. We copy the cat. We reverse the anode, if you guys still remember. Number 3, list the reactants. I'm going to show you this now. It's 4 beautiful marks. List the reactants. Number 4, if the reactants, list the reactants. If the reactants are the reactants in, you see now, in the half cell, then the reaction is spontaneous. Let's do this. List the reactants in the system. So we have, because we are going to have 2 of them. All right. List the reactants in the system. If the reactants are the reactant in the half reaction, then the reaction is spontaneous, and we would see the application of that. Then the reaction. Then number 5, apply. And there are different applications. I am going to start with my first application now. As a scientist in the lab, you must know what to store in what and what not to store in what. That's an application. You're not in the lab. All right.
Just a thought.
Just a thought, right?
That's great.
Okay.
Yeah, before you push the topic, you do the practical.
I'm sure you wouldn't mind sponsoring as well. Okay.
Think about it.
Number 1, application. Look at this. Storage of chemicals in containers. That's our first application. Storage of chemicals in containers. Let's look at a case. Let's build a case study just to show us. Is it safe to store zinc sulfate in tin is SN container? Yes or no? So I'm in the lab. I want to learn how to store my containers and my chemicals. Now I have zinc sulfate. Where should I store it? Should I store it in a container made of tin or not? I need to do electrochemistry to find out.
Is that how they ask me?
Yeah, that's one of the ways. Is it safe to store zinc sulfate? So I'm going to do one, you're going to do one. So I want you to follow. And we're going to follow these steps. Is it safe to store zinc sulfate in tin? What is our step one? Identify what is oxidized and what is reduced. Okay, so walk with me here quickly. 4 marks. Yeah. And I'll show you how it's marked. Guys, please get the language here. The language is the problem as well. This is tin. And what's the formula for tin? Sn. And then I have zinc sulfate. Is this safe? The first thing I'm going to look at is what are the reagents that I have? Look at your zinc sulfate. So if I have zinc sulfate, one thing I know from grade 10 is that I'm going to have it as what? Because it's aqueous, I will be having what? Zinc 2 plus, SO4 2 minus. Right? Please follow me. Zinc sulfate is in solution, so it's aqueous, it has charges. Aqueous. And then I have what? Tin solid. So what do I have here? I have zinc sulfate, zinc ions, and Sn solid. This is what I'm going to check. Yes.
How do we know whether we're reacting with the oxidation or the reduction?
We don't know yet. We don't know whether it's oxidized. We don't know whether it's reduced yet.
The formula you know is just from the
Zinc sulfate is just from the chemical that I have. Zinc sulfate, because it's in solution, it's ions. That's why I have zinc. I don't know whether it's oxidized. I don't know whether it's reduced. So zinc sulfate, because it's aqueous, it's like water. Water is what? H plus and OH minus. And
How do I get ions?
how do I get?
The ions. No, that's true. From that table.
Okay, you can also use the table. You can use the table to get your 2 plus. But there are some you must just know by default of doing chemistry for 3 years.
I didn't know it last year, didn't know it.
All right, but some you can just get it from the table. You have zinc plus, you have copper is 2 plus, iron, you have 3 plus there. We did that from the periodic table. So group 1 plus 1, group 2 plus 2, like that, group 3 plus 3. If you remember all of those periodic table explanations. All right, so I have this, and why is it again this? It's in solution. And that's my container, which is what? Obviously, my container has to be what? A solid. Let us compare these two by going to the table. We are now looking for which one will be oxidized and which one will be what? Reduced. And that's going to be the key to answering this question. So first was we identified. Now let's go to the table. Remember what we are looking for? We're looking for zinc and... No, that's going to spectator ions. All right, come, let's go down. For what? For
So we're only concerned about zinc. Yeah, the one that's in the thing.
the active ion. Oh, look at what we have. We have zinc. And what are we looking for again? Oh, check. So, what do we have on top? We have zinc here, and we have that here. Okay. Which reaction did we say would first happen? We said the one that will happen first is oxidation. Remember we said A and what? C. And here this is what? All right. Now check. I want us to write quickly our half reactions. We've already identified which one will be oxidized and which one will be reduced. You don't need to write this whole table. So you just get to your table, you've identified that. You know how we do it, right? we'll use the Z. So if I'm writing the oxidation reaction, where do I start from? Zinc will be oxidized to what? Zinc 2 plus. And for tin, we just copy cat. Are we okay, everybody? Can I move? All right. So this one, I'm going to give you one to do. So my half reactions would be this. What are my half reactions? Zinc, we know will become what? Zinc 2 plus 2E. All right. That's what we have, guys. Look, the second part, we would see it when we start dealing with other reactions. But for now, we'll just deal with the active ions. Yes, there's a hand for Anani?
So please explain again.
Which one for Anani? Did you miss last week's session, child?
Yes.
You've got to go catch up on that lesson. There was a whole lot going on there. First thing was, this is what we have. We have zinc sulfate and we have tin. We want to find out if it's safe. All right? So we consider that. And zinc sulfate, we said it contains what? Zinc 2 plus. That's my active ion. And then my solid container is tin, Sn. So what we did was we are going to compare this zinc 2 plus and tin. According to our 4B table, we said the one we find on top, which I'm going to explain in terms of chemistry now, is the one that is oxidized. And to write the oxidation reaction, we reverse the whole thing. So our oxidation reaction became zinc to zinc 2 plus 2E, and the reduction is that. All right? Now, guys, quickly check this. I'm going to make sure you get it. Please look at this. This is where the main thing is now. What do I have here on the left? Zinc. What do I have here on the left? Zinc, Sn2 plus, tin 2 plus. What are my reactants? Zinc 2 plus. Please, I want you to listen carefully here because I'm not going to write anything. In my system, what are the reactants? Zinc 2 plus and tin. In my half reactions, what are my reactants? Zinc solid. Do you notice that they are not the same? Don't worry about the right hand side. Don't worry about the right hand side. Focus on the left hand side. That's why I said if the reactant in the system are the reactants in my half reaction, don't worry about the right hand side. See, here I have Zn2 plus. But do I have Zn2 plus here? No, they are different. That's an ion. That's a solid. What do I have here? Tin solid. What do I have here? Aqueous. Do you notice that what I have here is not this? What I have here is not this. This is non-spontaneous. You're going to get it. Just hold on. The reaction is non-spontaneous. Hence, all right, I want to answer it in terms of chemistry, then I'm going to reverse it now. Okay, or don't let me conclude yet. Let me just do something. All right, check this. Don't worry. I'm going to reverse it now for you to see. All right, so we're saying the zinc, this is considering my half reaction, the zinc solid is supposed to change to zinc 2 plus, but I don't have what? Zinc solid. I don't know what I'm saying. I want you to get that point. This is what I am expecting to happen every time I have zinc and tin. I am expecting that the zinc solid will become zinc aqueous, but I do not have zinc solid. So this reaction will not occur. way you people are looking at me.
Because I was speaking, but I'm not hearing.
Okay, I want you to hear now. Look at this. SN, SO4, and I have zinc. Please listen, you're going to get it now. Do you notice I've reversed the two? Right? Again, what do I have here? I'm going to have SN2 plus and what? Zinc what? Solid. Because my container is a solid. The solution is what? Lovely. Whenever I have these two, if we go back to the table, we are still going to have this. So, this is what I'm expecting. I'm expecting my zinc solid to become what? Zinc 2 plus 2E. And my SN2 plus. Alright, look at this one. So we compare both of them. And I want you to hear me nicely now. In the first one, I had zinc 2 plus. And I had zinc 2 plus and what? Solid tin. In the second one, what do I have? SN2 plus and zinc solid. According to my reaction, anytime I have zinc and tin, that is what will happen based on our table. Wherever I have zinc, it must be oxidized to zinc 2 plus because this we got from the table. And SN2 plus will be reduced to what? That. Now check. Look at your left hand side. What do you have? Zinc and SN2 plus. That's exactly what you have here. Look at this one. You have zinc and SN2 plus. Do you have them there? No. No, these are products. That's why I said reactants. Look at point number 4. If the reactants are the... We are saying this will become this. Question. Do you have zinc solid here? No. Come here. Zinc solid will become zinc 2 plus. Do you have zinc solid here? Yes. It means this container will be eaten up into this. So this reaction is spontaneous. This one is not spontaneous. Why? For it to be spontaneous, zinc solid must be oxidized to zinc 2 plus, but I don't have zinc solid. Here, zinc is oxidized to zinc 2 plus. Do I have zinc solid? Yes. This reaction is spontaneous. In the lab, if you are a lab attendant, which one would you do? I would rather store zinc in tin than store tin in zinc. This is what happens when a metal rusts. You see, you have iron sheet outside. The rain is falling. After some time, what do you notice? There are holes. Do you know what? Have you ever asked yourself, where is that solid gone to? It has been oxidized. So this zinc container is now being eaten up and becoming what? Zinc. Look at what you're going to have when you, if you leave this over time, look at what you're going to have. The zinc there has been converted to what? Zinc 2 plus. Creating what? Holes. What will happen to your chemical? They fire you because you don't know what you should store in what. So this reaction will naturally, the one on the right hand side will occur on it. You don't need to do anything. It's like me putting chicken in front of you. We just know that the chicken is gone. Or like, let's use Red Bull. Okay, if we just put Red Bull in front of you, there's a spontaneous reaction to it. We don't have. If you put Red Bull in front of me, it will expire. It's not, I don't know if you get what I'm saying. It's not spontaneous. Please let me go over it again, everybody, so that you get it right. It's 4 beautiful marks, and I will show you where the 4 marks is coming from. First, what did we do? We identified the species that we have. In this one, what do we have? zinc aqueous and tin solid. Here on the right hand side, what do we have, my dear learners? We have what? Tin, which is what? Aqueous. Is that fine? And then we have what? Zinc, what? Solid. Anytime you compare tin and zinc, because we're going to talk about the strength when I answer the question, the reaction in the boxes would be my half reaction. Point 4 says, if the reactants are the reactant in the half reaction, the reaction is spontaneous. What are my reactants here? Zinc 2 plus and tin solid. Are they the reactant here? No. The reaction is not spontaneous. It will not happen. The reactants here, they are the reactants on the left. Oh, naturally, zinc will be converted to what? Zinc 2 plus. So this zinc solid will be converted to zinc 2 plus, creating what? Holes. The reaction is, it occurs on its own.
So oxidation takes place.
So oxidation and reduction will take place here. Nothing takes place here. It doesn't happen. That's why if I store the left one, if I leave it in the lab, it's okay. The one on the right hand side, not okay. By the time I come back in the morning after a few days, I will have wasted my chemicals. Why? The container would have rusted. How do I know it has rusted? There are now what? Holes in it. How would I write this answer? Check this. Step-by-step answer. Zinc is a stronger, please, these answers are very important, stronger reducing agent than SN2 plus. It is oxidized to zinc 2 plus. There will be holes in the container. There will be holes in the container, and it is unsafe.
So this is my answer from the table, right?
That's just the table. Yeah. Zinc is just now applying the information. Zinc is a stronger reducing agent, 1 mark, than SN2 plus, 2nd mark. It is oxidized to zinc 2 plus, 3rd mark. There will be holes and it is unsafe. We can say it's because it is what? Spontaneous. 4th mark. This one, reaction is not spontaneous. Oh wait, I think I saw one question like that. Reaction is not spontaneous. It is safe. Please, I want you to ask me questions on this quickly. If you just, when we are done, take some time, read the note again. It's going to make sense now. What I do is I check what is there. I write my half reactions. Now, do you notice what I was saying? That if Elena now knows how to write half reactions, look at, we've added another 4 marks, plus the ones we added the other time, right? So Elena now knows, oh, okay, I know what is happening. My zinc should become zinc 2 plus. Please always check something here. This one is oxidized. If something is oxidized, it's a stronger reducing what? Agent. So look at that answer the way I wrote it. Zinc, do you notice that I am not even making reference here? All my answers are here. Zinc is a stronger reducing agent than, I didn't say tin because I don't have tin. What do I have? SN2 plus. Everything is on the left. It is therefore oxidized to what? Zinc 2 plus. Therefore, there will be holes. Your zinc 2 plus is invisible, aqueous.
Why are you saying that it's a strong person like this?
Remember our table. Okay, I'm going to take you back to the table quickly. There's a question, why are we saying that SN is a stronger oxidizing agent? On the table, there are arrows there, and I want us to quickly look at those arrows. So enough of all the skills that we teach you. Let's teach you normal chemistry now, right? If you look at these arrows, this arrow is going down. Maybe you've not noticed it because we just quickly teach you tricks and we run away. Increasing strength of oxidizing what? Agent. That means as you go down, check. This one is a stronger oxidizing agent than this. Therefore, this is reduced. Look at the arrow going up. Increasing strength of what? Reducing what? Agent. As I go up. So it means this one is a stronger what? Reducing what? Agent. And therefore it is oxidized.
So both of them are reducing agents, but zinc is stronger.
Remember what I said last week? I'm very tall right now. And I'm also short. It depends on comparison. Look, if I compare zinc with tin, this will be oxidized and this will be reduced. But if I compare the same zinc with magnesium, this will be oxidized. Does that make sense? That's why, remember, I was explaining this reversible what? Equation or arrows. So we are not, the table will not conclude for you. It depends on comparison. I could be stronger than tin, but I'm weaker than magnesium. I don't know if that makes sense, based on where I am. So these arrows are very important. Look at it. Increasing strength of oxidizing agent, which means the one down is a stronger oxidizing agent than the one up. And if it's a stronger oxidizing agent, it is what? Reduced. Look at the arrow on the right. Increasing strength of reducing what? Agent. You can see it's moving up. This one on top is a stronger reducing what? Agent than the one at the bottom. Therefore, it will be oxidized. If you remember again quickly, in case you are confused about oxidizing agent and reducing agent, you come back to your table here, your equation. 3 marks. What do you notice? The reducing agent is oxidized, and the oxidizing agent will be reduced. Let me give you one question.
So how do we know whether we're comparing the oxidizing agent and the reducing agent?
You will always compare the two, always. The examiner will tell you, okay, look at this question.
And we see which one is stronger when we look at before we do the mistake.
Good. Once you write your half reactions, you're cool. Look at this one. Look at this. Guys, please, let's look at this. A nickel rod is placed. I'm going to answer this for you. A nickel rod is placed. So they've tweaked this question a little bit, but similar to what I did. A nickel rod, you can see the nickel is the solid, is placed in a beaker containing what? Silver nitrate what? Solution. All right? And a reaction takes place. Oh, wait, let's prove that a reaction takes place first, because I'm going to switch them. How will I know? Because I think I got the wrong question. There was a question I was thinking I was getting. What do we have? Let's quickly write what we have. What we have here? We have what? Ag plus, silver. And what do we have here? Nickel what? Solid. Before we answer this, is this spontaneous? Let's check our table. Never answer it from your head. Go to the table. What are you looking for in the table? You are looking for Ag and Ni. Come, let's go to the table. The table is your safe haven. There's nothing that you should be answering from your head. You are just going to apply. Okay, let's go down together for B. Where is Ag? Is it there? Okay, we continue. Remember, the table is There we go. All right. Where's nickel? Where's nickel? Is it up?
Yeah.
Up where?
Where?
There, where? There is there. Oh, all right. Check here. So remember, my table is, I just cut it into 2. Okay, so which one is on top? So nickel. Which one is on top? It's nickel. Which one is at the bottom? So which one will be oxidized? Nickel will be oxidized. So it's a stronger what? Reducing agent. Okay, so let me go back to this question now. We're getting there now. We're beginning to see what's going on. I love that. According to my table, I want to bring the table here. What do we have? We have Ni 2 plus 2E. Remember, it's a double arrow, right? You don't write this in your paper at all. Nana, I don't have a table here, so I'm bringing the table here. Never write double arrows. I mentioned that last week. I am doing this for reference. This is what you'll be doing with your own table. This is my own 4B table. Which one is on top? All right, so what am I saying? This one will be oxidized, and this one will be what? Reduced. Can we write our oxidation half reaction? What will it be? My half reaction will be what? Ni to give us what? Ni 2 plus 2E, and then what? Copycat Ag plus E to give us what? Is this reaction spontaneous? I'll guide you again. What do I have? Ag plus and Ni solid. Oh, it's exact. This reaction is spontaneous. So, which one is unsafe? Here they're not asking for safety. Okay. Please, they're not asking for safety.
But they're not asking for the question.
No, we're just answering now. That's why the examiner, if you listen to what I said, look at, the examiner gave you a statement and I just proved it. The examiner said, and a reaction does what?
Takes place.
They did not state what reaction.
No, it's already, we know that here I am just proving that a reaction will take place. Because what I have on my reactant, it's exactly what I have in the half cell. So already I know a reaction takes place. Hold on. Confirming the examiner's statement. We're cool like that. What if I have this? Ag and it's Ni2 plus, right? And I have nickel. Okay, I have Ni is 2 plus, right? Nitrate. Will it be spontaneous? Please check what I did now.
You have the Ni.
Please look at what I did. I switched it now, right? At first, my solid was nickel. I have made my solid what? Silver. My electrolyte is silver nitrate. It's now what?
It doesn't have a plus.
What do we then have here now? What do I have? I have silver what? Solid. And because this is a solution, it is what? Ni2 plus. That's what I have. Is it spontaneous? It will not be spontaneous. Why will it not be spontaneous? For this to be spontaneous, I need nickel solid. But do I have nickel solid here? No. I need silver ions. Do I have silver ions here? No. This is not spontaneous. On the other hand, this one is spontaneous because I have what? Silver ions and nickel what? Solid. So examiners are going to ask you in different ways. You must know how to apply that information. And I think, look, we've answered, you can answer all of these questions now. What is the name or the formula of the electrolyte? Silver nitrate. That one is staring right in your face. I'm going to help you with all of those. Silver nitrate. What is the oxidation half reaction? Already we are done. Nickel to give me what? Nickel 2 plus 2E. If you remember, I told you it's 2 marks. Can you balance that? We did the balancing last week. I keep saying last week. We did the balancing. What would you do to the balancing? You multiply that by 2. And your answer, okay, please do that quickly. You do it. Balance it. Balancing was done from grade 11. I'm going to give you one now again. Then I'm also going to add something to this. So please, you must be able to, if you don't understand spontaneous reactions, you won't understand galvanic cell. You can just cram what's happening, just cram, pass and forget. CPF. Are we done balancing? We should be done balancing. Come, let's say the 3 marks there. Because it makes noise and I like. All right, let's mark our balancing. Please, guys, make sure you are doing the work as quickly as possible. It's always nicer if you are just marking. That's my oxidation. Remember, what is this? A solid. And what is this? Aqueous. What's the next one? What do we have? Ag plus what? Let's learn to write this. It's going to help us in understanding. And this is what? Silver what? Solid. Our electrons are not the same. So what do? We multiply this by 2. And finally, if we multiply it by 2, what are we going to have? On the top, it's going to be what? Nickel what? Solid plus 2 Ag plus, which is what? Aqueous. And then what do we have at the bottom here? Ni, 2 plus, and 2 Ag what? Solid. My good learners, check. You've gotten yourself 3 marks. Left hand side, right hand side, and for balancing, you have 1 mark.
For balancing, is it okay?
What do you mean? Separately. Whatever you do, we don't even want to see that. This is what we want to see. That's all we want to see. You don't lose mark if you don't put the faces, but I love it because it helps me see what's going on. I love it because by the time we start talking about application, increase and decrease, blah, 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 it's going to be a lot easier. If I put a thermometer here, what's going to happen to the reading on that thermometer? Thermometer, will it be negative? You know, how will the thermometer reading be negative, my child?
It's gonna go higher.
Will it increase or decrease? It will increase. It increases, guys.
And the action takes place. It's an exothermic.
Good. It is exothermic. So this thing actually becomes warm. Heat is released. So the thermometer reading will increase. Yes, Gina.
Oh, I don't know. I can't see. Someone's camera's on. So you're talking about the solution?
Yeah, so what they do sometimes is then they put a thermometer right in here. You does it yourself. They put a thermometer here. Why will the thermometer increase? This reaction is spontaneous, and spontaneous reactions are exothermic. It means it becomes warm. If it becomes warm, what happens to the temperature of the reading on the thermometer? It increases. That's an exam question. Okay. All right. So that, guys, this is spontaneous. But I want to make sure that we are okay with it because I just don't want to jump into it. Please, which reaction is spontaneous? And I want you to explain the reaction now. Which reaction, this is your own question, is spontaneous? I have 2 beakers. You got to be fast with this for me, please. I have 2 beakers. Here, I'm going to have, let's have a rod. And another rod here. Let's have this in solution, that in solution. Here I'm going to have magnesium sulfate. Here, let's have Mg here. I can't have magnesium sulfate as a solid. I have Mg here. Here in the solution, I'll have magnesium sulfate. Here I'll have silver. Let's say silver nitrate. And here I have silver solid. Okay, please, I know you've written this, but it doesn't really matter. Let me keep the same electrolyte. Which one of this, reaction 1 and reaction 2, is spontaneous? You have 3 minutes. Please write that. I'm going to quickly go to the table so that in case you don't have a table, you can use mine. I have silver solid in magnesium nitrate, then I have magnesium in silver nitrate. Which one of them is spontaneous? Shesha, I'm waiting for you. Huh? No, I'm just waiting for Lesedi to quickly write a question so that I can go to the table for you. All right, here's your table, guys. That's the table, and I'm giving you 3 minutes to quickly apply. Which one is spontaneous and which one is not spontaneous? When we start answering the question, you're going to see it again. It's 4 marks. Don't run. Imagine the disrespect.
Imagine. Which one is spontaneous?
Yeah. Which one will be spontaneous and which one will not be spontaneous? Then you write, yeah. So you tell me why. The one that is spontaneous, you tell me why it's spontaneous.
On the bright side, you know the person sitting down and watching. It's a fun thing.
Good job.
Do you think we'll finish with syllabus next week? With math and physics?
We have to.
We can have classes on during the week. Monday, Tuesday, Wednesday, Thursday,
All right. So if I look at my case study, I'm basically comparing Mg and what? Silver. Okay, so if I look at the table quickly, which one will I find first? I'll find Mg first, right? Where's Mg is right there, and where's silver? Right here at the bottom. What does it mean? It means this guy is oxidized. All right. Okay. So I'm just quickly going to write my half reactions and apply now quickly, everybody, and then we jump. Where's my question? There we go. All right. So my half reactions quickly before I forget. My half reactions. Oxidation. Silver is Mg, right? Will be oxidized to give me what? Magnesium ions plus 2E. Silver ions are reduced to give me what? Silver what? Solid. Okay, let's come back to our sample. In our sample, what do we have? We have Mg solid here, and we have what? Silver nitrate here. For this one, what do we have? Silver what? Solid. Okay, which one do we have? I'm looking for that. Where is that? So number one is spontaneous. And this one is non-what? And simple. Why is that? I would say Mg is a stronger what? Reducing agent. Remember, keep your answers from the left hand side. Than what? Don't write Ag. It's not Ag. Ag is not on the left hand side. Ag what? Plus. Therefore, Mg is oxidized to what? Mg2 plus. Reaction is spontaneous. And you are done. You get all your marks now. Guys, I hope the spontaneous makes sense now. It means a reaction will just automatically what? Occur. The first one is spontaneous and the second one is non-spontaneous. That's our first application. So we can use this to know what to store in what. All right? So if I want to store, which one is safer? Is it safer to store magnesium in silver nitrate or silver in magnesium nitrate? It is safer. This one is safer. So if I want to store in the lab, I would rather have Mg NO32 and have silver solid there. I'll be fine. That's safe. It is safe because it is not what? Spontaneous. The silver will remain silver because in my half reactions, silver is not a reactant. Makes sense now? The other one, the one on the left, is unsafe. Because check, if I were to keep this and have Mg here and have silver nitrate here, what's going to happen to my Mg solid? Do you notice it will be oxidized to what? Mg2 plus. Hence, it's going to have what? Holes in it. Because the reaction is spontaneous. All right.
How to store things easily because I was grabbed.
Number two, second application, the galvanic cell. This is a spontaneous cell that converts chemical energy to electrical energy. Already I've mentioned two important things. Number one, it is spontaneous. Number two, it is what? It converts chemical to electrical. Example here is a battery. The makeup. The makeup. So our second application now is the galvanic cell. All right, you just came back. Check your answer. Which one is spontaneous, 1 or 2? All right, good. And that's your answer there. Mg is a stronger oxidized reducing agent than Ag plus. Therefore, Mg is oxidized to Mg2 plus. Reaction is spontaneous. Case closed. 4 marks. All right, so our second application is the galvanic what? Cell. Let's fly on this one, guys. Fly like fly, fly, fly. This is a spontaneous cell. Yeah, the first application was the first one there. It's a spontaneous cell that converts what? Chemical energy to electrical energy. For example, your battery. It's also known as a voltaic cell, in case you want to just add that to your name. Voltaic, because it produces volts. It produces what? Volts, because we measure it in volts. It is exothermic as well. I did mention that earlier on because it's spontaneous. All right. What is the makeup? It contains, okay, let me do foundation. Oh, yeah. Okay, powder. Okay, waste of money. Half cells. Continue wasting money there. Half cells. It contains half cells.
I need to, because I didn't look up all I was.
I forgive you, people. What? What is a half cell? Okay, we forgive each other. What is a half cell? A half cell is either oxidation or reduction cell. But what it is a cell that contains an electrode. Remember we spoke about an electrode. What's the other way I told you to remember electrode? I said it's an electric what? Rod. We mentioned some things about electric rods. What did we mention about electric rod? We said it's a solid, it's a conductor. Remember? Electric conductor. Rod, solid. All right. It is a cell that contains an electrode, and an electrode is an electric rod, or let me say dipped into an electrolyte of its kind, e.g. copper solid in copper sulfate, zinc solid in zinc sulfate of its kind. We don't want to put zinc in copper, copper in zinc, right? Of its kind. So you'll be looking at something that looks like this. And you have an electrode there. This is an electrode. What are the properties of an electrode? Number one, it must be what? A conductor. And number two, it must be what? A solid. And then this would be what? An electrolyte. Quickly. If I were to quickly look at an electrode, it's there for the passage of electrons. What about an electrolyte? An ionic solution that conducts electricity. Grade 9. Natural science.
Yeah, that's it.
You okay? through the movement of ions. They are usually metal salts. Best electrolytes are nitrates. Grade 10. All nitrates are soluble. I'm going to quickly mention something here which we're going to carry across. The best electrolytes are nitrates. Chlorides are good. Chlorides are good. Except for silver nitrate, no, silver chloride, which is, and that I wanted to keep that particular one. There are more. Chlorides are soluble except that of silver, mercury. All right, but I wanted to keep this one. Silver chloride. Please, very, very important. Silver chloride. I'm going to deal with that silver chloride before the day is over. All right. Please take note of the formula of that silver chloride. AgCl. Except for silver chloride, it's a solid. It is a solid. So silver chloride is not good. Once you see silver and chlorine, please start taking note of that. If an examiner asks you for an example of an electrolyte, use nitrates. Then you are safe. NO3. All right. We can also add sulfate here. Sulfates are also good. Yes. So nitrates are usually the best. All nitrates are soluble. If you remember solubility in grade 10. All right. Chlorides are soluble. There are 3 that are not soluble. But the main one that we'll be using for complications will be silver. And I'll tell you where the complication is. So here is my half cell. What do I have in a half cell? I have an electrode and an electrolyte. The electrode is solid and a conductor. The electrolyte is an ionic what? Solution. Example, copper sulfate, zinc nitrate, silver nitrate, not silver chloride. Please, in your note, highlight that silver chloride for me. That, I will keep ringing that bell until you write. You would not hear me say silver chloride after writing, but we will keep mentioning that. All right, so that is my half cell. And in a galvanic cell, we are going to have what? 2 half cells. We are going to have 2 half cells, 1 reduction and 1 what? Oxidation. It would not be in the same. Okay. All right. Number 2. What is the makeup? We've done the foundation.
Yes.
Now we need what? What do we need now?
Blush. Yeah. Concealer. No, concealer first.
Concealer.
So it's your foundation. Yeah. Then you concealer.
You need help.
Then it depends what you want to do. Some bronzer.
But let's
What? Bronzer.
Bronzer.
Oh, my God.
That was the foundation and the concealer. Let's move on to the blush.
Yes, and then blush. You need like a pigmented blush. And then you can also highlight. A highlight is like
This
really
video
good.
is-
It's so dope. You should get one. I cannot forget a good lip combo mixer girl. You need one.
All right.
You should get one.
A salt bridge. That's what I need.
One last thing. Get yourself a lip therapy from this camp. It'll make your lips pop. I feel like it's overrated.
God will help you.
It is overrated.
All the women in this class, God will help you. Both those online. Hi, Bonolo.
Hi, sir.
How are you?
I'm okay, how are you, sir?
I'm okay. They said I should buy you foundation.
What?
That you want to build a house. A foundation for makeup. For makeup. It's Gina.
But you can like for makeup artist.
Okay. Good luck with your makeup artist. Let's do Salt Bridge. That's a very good makeup. But it it contains a highly. She's ill-advised. It contains a highly saturated ionic salt. Which is inert. Which is, the word inert means does not react. E.g., sodium chloride. These are the two main ones that we should be using. Sodium chloride, or let me say 3, or sodium nitrate. And I'll tell you when also to use, but basically sodium and potassium there. I wrote this twice. All right. How does the salt, what is the function of the salt bridge? It's a bridge. It, yeah, it's like a YouTube thing. It completes the circuit, because remember it's a battery, so it's a circuit, number one. Number two, yeah, we're looking at the battery. A galvanic cell is a battery.
The inside of a battery. The inside of a battery.
Yeah.
So if it's not there, we won't have electricity.
It completes the circuit. It maintains electrical neutrality. This second one, learners always forget it. In the half cell. And you know what the examiners will tell you? Apart from completing the circuit.
They like doing that.
Yeah, because everybody just knows it completes the circuit, So to catch you now, they say,
Would be the only thing you learn for the exam. And
so please,
from what you learn.
every time I ask you now for function of salt bridge, let's try to use the second one more. Neutrality in the, let's just say, in the half cells. What's a half cell? A half cell is a cell of electrode and the electrolyte.
The atom is a half cell.
Nah. Huh? A half cell. That's a half cell. Electrode and electrolyte.
So is it, when you say to maintain the electrical neutrality, is that in like, which you don't like to, is that to basically
You'd see what I'm going to do now. All right. It maintains electrical neutrality in the half cell. The question is how? How? So I'm explaining number 2. The anions in the salt bridge. If you remember when we wrote cell notation the other day, we said bridge. That's the bridge we're talking about. And we're not there yet, don't worry. The anions in the salt bridge move. Do you remember this note? Do you remember this one? That's what we started with today. The anions in the salt bridge move to the anode. The cations move to the what? Cathode. To neutralize the ion deficiency, let me say the charge deficiency I'm going to explain this. And excess. Okay, we look at the salt. We look at the whole cell now. We're done with the makeup. Oh, the cations move to the cathode to neutralize. Oh, sorry. To neutralize the charge deficiency and the charge what? Excess. I am going to quickly explain now, my good learners. Or before I explain, let me quickly do. Oh, there's something I was supposed to have done. All right. NB. If the half cell contains a gas or a non-conducting element, we introduce let me say, I want to do it once. We introduce a platinum electrode or a nickel electrode, but usually we stick to platinum mostly, so I'm going to underline that. All right. Why platinum? It is inert. It is a conductor. Remember, we spoke about the word inert. Inert means it will not react. And number 3, it is a solid. Okay, we're going to jump into the half cell now, guys. These notes are very important. Huh? Why? All right. I love the question. Why what? Why do we bring in platinum?
Because it's not going to act in the same.
All right, lovely. I love what you just asked now. What did we say should be in the half cell? It's a solid electrode and an electrolyte. Let me show you a diagram quickly. Let's say just one second. I know you're writing. Just to quickly show this. Okay, look at this. This is a simple makeup of a galvanic what? Cell. That is one half cell. That is another half cell. This is an electrode. What you have here is an electrolyte. All right. Do you notice that are solid? Okay. Look at this. I'm going to show you one now. I think I've got a picture. Look at this one. This is now what? Hydrogen what? Gas. So I'm now using a gas. But I want my half cell, it must have a solid. Hydrogen is not a solid. Because there's no way, if I remove this whole rope here, electrons are supposed to flow. But this is a gas. Electrons will not flow. So what do I need? I need something that is a conductor and that will not mess up my whole experiment. That's why we use what? Platinum. So we use platinum because number 1, it's a solid. So already we have fulfilled what an half cell should have. Half cell should have what? A solid electrode. So platinum plays a very important role there. It is solid. Number 2, it's a metal. So it conducts what? Electricity. But it will not react. What's its job? Its job is just to allow electrons to flow. Remember, electrons will flow from the anode to the cathode. And the flow of electrons is electricity, which is what we're going to look at shortly now again. So the reason we use platinum is to be able to have a solid path for electrons to flow. What the examiners will ask you is, why choose platinum? We choose platinum because it is inert, it's solid, and it's a conductor. Are we okay?
What is the actual going to serve as the conductor?
Because if I'm using hydrogen gas, hydrogen is not a solid.
Needs to be non-spontaneous.
No, the reaction must be spontaneous.
No, I mean the metal shouldn't be available.
Yes, so if I use something else, it's going to mess up with my chemical composition. All right, so that's why we say it is inert. So I am still coming back to maintain that my half cell must have what? A solid electrode and my electrolyte. So if I have a gas, what do I need to do? I need to introduce what? Platinum or nickel. But most of the time, we just stick to platinum. It's mostly used. All right. Why platinum? It is inert, it's a conductor, and it's a solid. All right. Quickly, let's look at the process of galvanic cell. I should actually start with what you call a standard hydrogen electrode.
Oh, I know that.
A standard hydrogen. All right. I'll tell you what, I'm not going to spend much time on it. All right. A standard hydrogen electrode. But I won't do that now. That's why it is inert. All right, my good learners, there's a myth that people always have. Oh, learners always have. A very serious myth. Huh? No, it's not. Learners just believe that the anode must be on the left-hand side. And I don't know where they get that from. It's a terrible, terrible conclusion. All right. Please, I want to explain this. What we have here is a galvanometer. All right.
A scenario doesn't have a circle.
Which one?
Like the diagram, if you have a scenario, doesn't have the circle.
Yeah, I could put a light bulb there.
So it has to have like a source of
It's not the source. It's just to read
that you see that electricity
current. Yeah.
passing through.
All right. Here is the slide for 2 seconds, guys. This next one is very, very important. Noloazi, quickly. The next thing is very, very important. I'm going to explain. It's going to look dirty in a minute. It's going to look really, really dirty in a minute. Noloazi, let me know once you're done. Huh? Yeah, we bring in all the makeup now. The brown one, the red one. Oh, if you do makeup, then you become like a masquerade. I know you're done. All right, a blush.
That's all you need for makeup.
This is going to be my half cell. And this is going to be another half cell. Let's use examples. Let's use aluminum and magnesium. I don't know which one is the anode. I don't know which one is the cathode. So just a case study. Would that be fine? All right. Let's say I have aluminum solid here. And I have magnesium there. So the first thing, those are what? Electrodes. And by the way, they should be what? Solids. If you listen to this, all the notes, everything I've written in words, I'm going to be putting them here now. So this is very, very crucial. What do I have in my containers? What will I be having? I'll be having electrolytes, right? Okay, please, I said something. The electrolyte, the electrode should be in an electrolyte of its type. So my electrolyte, let's use nitrate, all right? If you want to know how to write those formulas, look, aluminum is Al3 plus. What is nitrate? NO3 minus. By the time I combine them, the 3 goes to the side. If you remember that in grade 10. Okay, let's leave it. ALLO3, 3. Okay. Here, check this. Magnesium is 2 plus. Nitrate is what? So what do? These 2 would come there. And what are we going to have here? MgNO3 and then what? 2. Those are my electrolytes. electrode, and what is this? Electrolyte. This thing here is known as my salt. They'll ask you to label this. Salt bridge. What is the function of a salt bridge?
It maintains electrical neutrality.
Oh yes, this is very important. As a conductor.
It completes the circuit, all right? And it the electrodes are the conductors, and it maintains electrical what? Neutrality. Please don't forget the word electrical. That's why I use the word charges. It maintains electrical neutrality. All right. What does it contain, by the way? It contains a highly saturated ionic what? Salt. And it must be inert. It's there in the note. It's in your exam guideline. Highly saturated. Okay. Yes, it's important. Important. Now, please check. Do you notice I have nitrates? I'm going to stick to a nitrate. So I can use sodium what? Nitrate. Oh, since I don't have silver, it's fine. But let's use, it's fine. Silver nitrate. It's okay. Sodium nitrate or potassium nitrate. All right, guys, we want to look at the process. Can you tell me which one is my anode and which one is my cathode? Please use the table. What am I comparing? I am now comparing what? Al and Mg. Which one will you find first? Is it Mg?
Yeah.
All right, Mg is first. And where's Al? Oh, they are neighbors, right? Lovely. What a good one. All right. So anode and cathode. That's very, very important. Oxidation and reduction. So that's my first thing. Guys, by the way, are you aware that I didn't do anything to this thing? I just poured chemicals, put wires, and that's all. All right. So we know that here, this is going to be our what? Our anode half cell. I'm going to put it here quickly. This is the anode half cell. And what will this be? All right, cathode half cell. Is there any question so far on this? Cathode half cell. How did I get that? I used my table. What is the reaction on the anode side? What is it saying? Oxidation. Beautiful. Oxidation. Okay, by the way, anode half cell, it's getting dirty, right? Oxidation. What's going to happen here? Reduction. Can we write the half reaction? The half reaction that occurs at the half cell. This is magnesium. Half reaction will be what? Mg solid is oxidized. You remember my reaction, right? You remember how to write this. Mg2 plus what? 2E. What will happen here? Al3 plus 3E to become what? Al. Guys, we have gone past this now. You know how I got those reactions, right? ANC and Zuma. We copy the cat. So we are now very sure of what's going on. Gina, that space. Okay. You just have to write a bit small enough. Guys, I want to explain what's going on now, and I need you here. What's happening step by step? What's happening? No, you'll be fine. Don't worry. What's happening at the anode? The solid. Check this. What's happening? Oxidation. What's oxidation? It is the loss of electron. So, what am I going to be having? My good learners, please check. I am having Mg2 plus. And my electrons are going to move this way. I just broke down that equation now. Please look up quickly. Look at my half reaction. What do I have? Mg solid, Mg2 plus, 2 electrons are released. That's my Mg solid. By the time it loses 2 electrons, it becomes Mg2 plus.
So every time it
Becomes an ion. How are my electrons moving? Okay, I'll need you to focus here. Whatever that was, you copy later. How are my electrons moving? We said electrons are moving from the anode to the cathode. So can you see that electrons are moving? And what are electrons, by the way? Electrons are considered as what? Charges. They are negative charges. Wait, what's happening? It's a flow of... Wait, when electrons flow, what do we call it? Current. Did we have current at the start? No. Can you see that the cell is spontaneous? We have now converted chemical energy to electrical what? Energy. This we can use to measure the EMF. No, EMF. Because we are measuring potential difference. So electrons are flowing from the anode. Wait, so what do you have here? Loss of... You take a picture of this, don't worry. What are we going to get here? The gain of electron. Oh, wait, because it's a passage. What's happening? The electrons are coming in here, right? Watch this. Watch this. What's happening? The electrons, look at this. Look at this, beautiful. The electrons are getting into the solution now. What's going to happen? Beautiful. What is going to happen? Please, I wish I could.
So excited.
You're so excited to see what's going to happen. Wait, what do we have in the solution? Aluminium nitrate, right? Wait, but aluminium nitrate simply means I have Al3 plus. Right. So what's going to happen? This Al3 plus will be receiving this what? And what are we going to be forming? Aluminium what? Solid.
Don't you like free electrons?
No, yeah, there's a lot of electrons coming in, so that's why we balance. Right? That's why we balance. Yeah. So this one, for 6 of these, I'll get 2 of that. Okay, that's the balancing part. But right now, we're just looking at the process. So, electrons are lost, yeah? Are we there? The electrons come here, check. They get, remember, what is your electrode? It's a passage for electrons.
That's why it used to be solid.
That's why it must be a solid. It's a pathway for electrons to flow. So electrons get into the solution. When they get into the solution, what do they find? Al3 plus.
And then it makes it into solid.
The Al3 plus then gains what? Electrons and becomes what? A solid. Wait, if it's becoming a solid, reduction takes place. If it's forming a solid, we're going to have a solid form there. What's happening to the size of the cathode? It's increasing. Meanwhile, what's happening here? The anode will decrease in size. For anode, the remember, we are losing weight. We are gaining weight. Do you know who's here, right? Obvious.
Wow.
No, gaining. Cathode. She's just gaining, eating the husband's money. Eating the husband's money, just chowing the money. The husband is getting thinner. You told me. The wife is getting on the other side, gaining. You know, you will see right now, even that when I want to write my cell notation, I'll be using that again to explain. I just love it.
She's making time.
But wait, I wanted to see something, guys. I wanted to see something. Please check. Please, guys, are you all of these notes we have? I'm just putting the whole picture now. Okay, wait. What do you notice? Do you notice that you should be able to explain this to anybody right now, step by step. What was the first thing we said? Number one, because this guy is a stronger reducing agent, it will be oxidized and it loses what? Electrons. While it's losing electrons, what happens? There's a loss in electrons and what? A decrease in the mass. Again, you can look at the half reaction to explain that. The solid is becoming what? Aqueous. The electrons are transferred. There's a gain of electrons and what? A gain in or an increase in mass. What is causing the increase in mass? The mass is increasing because we are gaining what? Electrons, and the aqueous is becoming a solid. But as all of that is going on, please look at this. This thing here is becoming more positively charged. Do you know why it's becoming more positively charged? We are losing electrons. Electrons are negative. So we are losing electrons and Mg2 plus is increasing. Okay? On this other side, what are we doing? We are gaining electrons, and as we gain electrons, please check. The Al3 plus ions are decreasing because it's now becoming what? A solid. So I'm going to write it here. Al3 plus ions are what? Decreasing. And this side becomes what? Partially what? Negative. Does that make sense? Or let me write partially. Let's write partially positive here. Why is it becoming partially positive? We are losing electrons and we are having Mg2 plus. On the other side, what's happening? We are gaining electrons and we are losing. This is where your salt bridge kicks in. To maintain a balance. I don't want one part to be more positive than being negative. It maintains neutrality. Wait, since the right hand side is becoming more positive, what should we have there? So my sodium nitrate would break down into what? Na plus and what? NO3 minus. What are this? These are called cations, and these are called what? Anions. Wait, hold on, check something here. This side is becoming more partially positive. To maintain it, what do we need? Negative ions. The examiner is going to ask you for this.
If it's not asking.
No.
There's space if I need.
Do you notice what I said?
It's so small.
Sorry.
You're gonna get down.
And the positive ones will come in here. So that we maintain what? Electrical neutrality. Just take a picture, Gina. Wait, do you notice what I said earlier on? What did I tell you? I said the anions will go towards the anode. How will they ask you this? They won't write anything. They just write that. They'll show you ions moving. You must be able to know that the anions will go towards the anode and the cations will go towards the to maintain electrical what? Neutrality. Guys, ladies and gentlemen, this is your galvanic cell. It is spontaneous. It is exothermic. It happens on its own because on one side we are losing electrons, on the other side we are gaining. The flow of electrons create a potential difference, and that's the voltage that we want. Now we can calculate the EMF of this cell, can't we?
Yes.
You are like now.
No, that we did last
Yesterday.
in the last class. We should be able to calculate.
Yeah.
But I want to I want to show you how we write the cell notation. I'll be done. So please, there's so many. If you're an examiner, check how many things you'll be able to test here.
So, sir, we are done with this topic.
No.
Then we are done. As though we are going to with distinction.
Let me see your bag. Huh?
Guys, are we okay here? All right. I quickly want to tell you a love story before I finish, and that's going to be my last session
So you're done?
for today.
Oh.
Okay, but look at this love story, guys. I want to write what I call, okay, just to quickly check, what will be the EMF of this cell? I'm sure we can, let's calculate it. It's 4 marks. EMF. What do we say? E cell equals to what? E cathode, talk to me, minus E what? Anode. What is the value of the cathode? Which one is the cathode again? Aluminium. Please check the value for me, negative 1,76, I think.
66.
Negative 1,66.
2,36.
Negative 2,36. And what would that be? 1,7.
Yeah.
1,7, right? Huh?
0,7.
Oh, 0,7. And it's a positive value. And it's volts. Remember, how many marks are you getting here? 4 marks. Cell notation quickly. How do we write? I'm going to tell you a quick story here. Cell notation. And it's a beautiful love story. Huh? Yeah. When I say love, it's women, of course.
Sure, life for us.
All right. Where is the cathode? Which one is gaining weight again? The cathode. Okay. The aluminum, which is the cathode, right? And there she is again.
She is.
There she is. Big hair. And there is the gentleman bishop. Oh no, Bishop doesn't have hair now, so let's bold Bishop there. Just some nice little cute guy. All right. Cute dude. Cute dude. Do you want to record this one for me? I want to use it as a short. Record what I'm doing here. I want to use this. This is going to be beautiful. All right. Okay. So, no, don't worry, don't write. But I just wanted to follow. So this is a love story, guys. A beautiful love story. And this is Bishop. And what is this? Who's this? If you remember organic chemistry, this is Susan. Sue baby. Do you remember organic? Where Bishop went to the... Okay, so this is Sue. Sue is pregnant because she's been gaining. She's the cathode. But all of a sudden, Sue looks into the sky and there are these little birds, many of them. And her first reaction is to cry for help. All right. Help! 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 Crying so loud. And I'm on that side, right? What is my first instinct as a good guy?
Run.
I want to run to save her. But unfortunately, I can't run away. Unfortunately, wait. What is here? There's current. I won't say I love Sue and run over this wire. Check this. There's current here. I'm going to be electrocuted. And if I get electrocuted, somebody else is going to come save my Sue. And I don't want that. It's me who must save my Sue. I must get all the thank you. Now, I want all the thank you. So what do? Is there another passage? Yes, there is. I cannot pass this place because it's dangerous. So what do? Look at me. I'm going to slide down. Action movie now. Dun, 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 dun. The things we do for love. Dun, 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 dun. I get in. Please watch where I'm going. I start from the solid, right? I slide down the pole. Bam, bam, bam. I'm going to jump into this swimming pool here. Okay, beautiful. This is me gasping for breath, although I can't swim. All right. But hold on. I'm going to now get here and quickly jump on this what? Salt bridge. I'm now running. I'm coming, baby. I'm on my way. I'm gonna get there soon. I'm thinking the challenge is over. What do? I jump again into another pool here. Are you seeing the path? I jump again into another pool. This girl is very far. But because I love her so much, what do? I have to climb on this electrode until I get here. Aww. And I say, and I become a knight in a shiny what? Armor. And then she can kiss the king. And kiss the prince. Boo what? You should be praying for someone to save you like this.
I don't need saving. I'm saving myself.
You can't save yourself, girl. No, you can't save yourself. You need your James Bond to come and rescue you. Yeah.
No, we don't.
You got to get a James Bond with a gun, and I get my gun and shoot all of this. But hold on, where did I start my journey from? Let's get back to chemistry. Remember where I was? Where was I? I was here. Where did I start climbing from? I came from here, right?
Yes.
From where?
From the
Mg solid. Then I moved into the solution. What is in my solution? Are you seeing that, right? Then from there, where did I go to? I climbed on my, talk to me, on my salt bridge. When I got from the salt bridge, I jumped back into the solution, which is what? Aluminum nitrate. Then I climbed up. Do you notice I started from the solid and I ended up on the solid? How do I write my cell notation? That's my love story. Where did I start from? I started from the solid. All of that just to write this. Remember, we said the cell notation is as simple as A, B, A, B, C. 1, 2, 3. Of course. I've been around for a while now. Okay. What does ABC mean? You guys are laughing there. Anode. What is my B? Okay, now we know the type of bridge. So let's be specific. It's the salt bridge. And then we have what? The cathode. Quickly, things that I must write on the salt bridge. It starts with, or it starts and end. Yes?
How will I know that they want me to explain it?
They will just ask you to write the cell notation. It starts, they will just ask you for the cell notation.
I know this one.
What?
This one.
What you know?
This one's of writing it like.
Yes. Just follow me. Give me 2 minutes. Now I'm going into details, right? Remember that one I did? I was showing you that if Elena knows the anode and the cathode, they can just get the 3 marks. But now I want to quickly go in details. Just imagine knowing it. Not knowing it, right? Lovely. So please hear the rules. It must start, it starts and ends with what? A solid. Number 2. If the phases are different, if the phases in the half cell, we'll look at that now next session and end it. Half cells are different. We use a slash as a phase, I call it a phase separator. If same phase, because I'm going to look at case study in our next, if same phases, we use a comma. And we use 2 slashes, or some people say strokes, for the salt bridge. So in this case, I want us to quickly look at what my salt bridge would be, and that will be it. Please, it must start with a solid. So when I use platinum, I must introduce platinum as well. It must start with a solid, and it must end with a solid.
Oh, then peppermint is
Yeah. So we're still going to maintain that rule. And we start from the anode to the cathode. So what's my anode in this case? Okay, Mg. So it's going to be what? Mg solid. That's where I started from. Then remember I went into the pool. What was in the pool? Mg2 plus. Which is a no. Just write the active ion. Mg2 plus. And that's what? Now that is my anode. But do you notice that there are different phases? One is a solid and one is a liquid. What do I do? Phase separator. I must put that. That's what it does. Is to tell me that they are in different what? Phases. I'm done with the anode. A. What's next? Salt bridge. Are we there? Oh, there's something I just remembered, but it's okay. Salt bridge.
When do you use the color? When we have a solid in the.
Now I'll show you. I'll give you an example. Now next one where the comma would come and where there'll be the same faces. All right. What's next? The cathode. Check my swimming. After the salt bridge, I went again into the pool. Right. So it has to be what? Al3 plus. And then I came out by aluminium what? Solid. Again, that becomes my cathode. And remember, what is this single stroke? A single stroke is what? It's a phase separator. And what is the double stroke? Salt bridge.
Thank you so much, sir.
Okay, but
not now.
No.
You can say thank you now.
all right, just 1 minute. One. Oh, wait. Just before I said I remembered something now, just to quickly add to it, so that when we come back, we just answer. We just do the next one now. We're going to do the one with a gas, where we bring in platinum, and we answer questions. We talk about contamination, and there's what we call contamination of a cell. Yeah, then we bring in the Chatelia's principle again. Okay, but quickly, finally, for the last just 2 minutes or 1 minute, my last lesson, last slide for today. Standard conditions for a galvanic cell. These are easy marks. Standard conditions for. So galvanic cell is done under standard conditions. Number one.
The person who is translated the audio.
Number one. Pressure, temperature. Temperature. And the temperature is 298 Kelvin. One second, I want to show you something quickly. Where is my formula page? It's 298. Check. Please look at it. That's where you get it from.
Okay, why is pH there?
No, pH is for acid and base. All right? But that is a cue of where to get. So this thing is done under that same standard what? Yeah. Because we have what you call auto what of water. Okay.
Can we do the experiment?
You want to do the experiment?
Get it from school, ask Mr. Moy.
Okay.
All right. Number 2. So please take note of where to get that. The temperature. So our standard temperature is what? 298. The next one is concentration. The concentration of the electrolytes must be 1 mole per dm cube. And finally, pressure will be 1 atmosphere. But pressure is only mentioned only for gases. So like the picture I showed you for hydrogen, they will ask you for standard conditions there. In this particular one that we used for our case study, did we use a gas? No. So don't mention gas pressure there if they ask you for standard condition. And don't just say pressure and temperature. You have to write the values. The temperature has to be 298 Kelvin and the concentration has to be 1 mole per dm cube. But if I give you one like this, where is that one again? If I give you one like this, then what do I need to do? I must mention what? Pressure. Guys, what is the function of platinum? It's an electrode. Energy conversion, done. Function of Q, done. Half reaction, done. Cell notation, done. Without me even saying anything, we have done all of this. Check. What is the function of the platinum? It acts as an what? Electrode. Is that okay? It's the electrode for conduction. Write down the energy conversion in this cell. Chemical to electrical. What is the function of Q?
It maintains the electrical neutrality.
Lovely. It maintains electrical neutrality of the circuit. Number 2, it completes the circuit. Any one of that. Cell notation. First, I need to identify which one is my anode and which one is my cathode by comparing on the table, right? What will I be comparing in this case? I'll be comparing what? Mg and hydrogen. But from experience, Mg is on top. So electrons will be flowing from here to here. Does that make sense? So instantly, do you know I can write my cell notation without stress? Because you know your anode and your half reaction that occurs at beautiful. That's my cathode. Copy cat. All right. Cell notation, 3 marks. EMF.
Wow.
Because you are
in my pocket.
boom, 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 boom.
18 marks in my pocket.
The only thing I'm going to explain, further is this one. But even if I do, it's 1 mark. You can give the examiner, but don't give the examiner. But I don't know if you guys are seeing that we are good here. Wait, what's the correct answer? You get this one and then you go. No. In the electrochemical cell, the letters X and Y represent 2 metal electrodes. All right? Check. When the cell is functioning, electrode X gains mass. So what does this tell you?
It is cathode.
Good.
Undergoes reduction.
Lovely. Undergoes reduction. That's my anode. How would you write your cell notation? Which one is correct? Remember, they said cell notation is ABC. Okay, which one are we starting with? Oh, by the way, it must start and end with solid.
Solid.
Good. Are you aware that all of these are out?
Yes.
We are now struggling between A and B. But what is X? The cathode.
These are cathode.
Good night, everybody. 2 marks in the bag. We're done.
I wish they would ask.
Yeah, we start with the anode, and anode is the Y. So, Elena who doesn't know
The freaking lady.
that
What's causing this sexist?
would struggle. Good.
No.
Good night, everybody. Bushra says, good night, good night. Can we get the audio for the lesson? Should we make it available for everyone? Should we make it available for everyone?
Sir, thank you so much. I really appreciate it. It was so lovely to watch the lesson. Could you please, because the learners wanted to see, I would really appreciate you please give us the audio or the recording of the lesson.
Who am I speaking to?
Bushra,
Oh, from which school?
Ridgeway Muslim School.
Oh, okay. Are you a teacher there?
Yes.
Awesome. Okay, I would make it available. It's going to be on my YouTube channel.
Okay, sir, how can I access it? Could you please write the link or your name so we can just click it?
All right.
How would you access that?
You just check Crazy Physics.
Perfect, sir. Thank you
All right.
so much. I'm just gonna take a screenshot and then we'll go there.
All right. Make sure you
Thank you
like,
so much, sir.
Like.
Thank you.
comment, and subscribe. Boo, 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 boo. All right, guys. Have a lovely evening, everybody.
Showcase is such a good teacher.
All right, bye, guys.